Welcome back. Let's do a few more word problems here. Let's say we have a full bag of chips, and this bag of chips has 80 chips in it. 80 chips. How many chips are left in the bag after you've eaten some? Okay, well, we're actually going to have two variables in this equation, and let's go ahead and define them, and I'll show you why. Let's say we're going to let x equal the number of chips that we eat. We have a bag of 80 chips and we're going to eat some. So x is going to be the number of chips eaten. And we're going to let y equal the number of chips remaining. Okay, so we have 80 chips. We're going to eat a certain amount x and we're going to have a certain amount y remaining or left. Okay, we want to know how many chips are left in the bag after you've eaten some, so we want to solve for y. Y is the variable that we want to solve for. We want to know how many chips we have left. So how do we do this? Well, we have original amount of 80 chips, and we're going to subtract an amount, and that's the number of chips that we eat. So 80 minus x. All right, and then let's say that we want to know how many chips are in the bag after we've eaten 18. So what we're going to do is we're going to define x as 18. So we have original amount of 80 chips and we eat 18. So what we do is we're going to plug in 18 wherever we see x. We learned this in solving equations. We actually learned it in solving, evaluating algebraic expressions, and it's the same thing with equations. So y, the number of chips left, is going to equal our original amount of chips, 80, minus the number of chips we've eaten, which is x. Well, we're saying that we're eating 18 of them, so we're going to plug in 18 for x. We want to use our parentheses. And this is straightforward. 80 minus 18, or 80 plus a minus 18, is 62. So y equals 62. Now, this seems very straightforward and common sense, that if we have 80 chips and we eat 18, well, we can just subtract 18 and get 62. While that's pretty simple, we want to get a good foundation of taking a word problem or a real-life example and writing out an equation that we can solve. Because what we can do with this is we can reuse this equation for any value for y or any value for x, instead of having to think about it or rewrite it, or even for real-world situations where it's not very straightforward. We can't just say, well, this minus this is just this. We have a lot more stuff going on. So we want to get in the habit of being able to turn a problem into an equation that we can solve. Now, as always, when we have an equation that we're solving, we always want to check our answer. We check our answer by substituting our answer, y equals 62, into our original equation to make sure it holds accurate. So we're proposing that y equals 62, so we're going to substitute in 62 for y, and that should equal 80 minus x. Well, x in this case is 18, so 80 minus 18. Well, and if this holds up, then that means our answer is correct. So we have 62 over here equals 80 minus x is 62. 62 equals 62, that's a true statement, so our answer is correct. Okay, like we said in the previous video, we should never get an equation wrong as long as we check our answer. Okay, so we can be sure that we get 100% of them right. This only takes just a few moments more, just a little more work, but it's well worth the work if we can make 100 every time. So just something to keep in mind. Let's get in the habit of checking our answer. Let's go on to another one. Let's say we have a group of people at the mall. Let's say after 40 people leave, we have a group of people at the mall and 40 of them leave. We find out that 3/4 of the original group is left at the mall. So 3/4 of the original amount, or the original group of people, are left. We want to know how many people were at the mall in the beginning to start with. Okay, so we're going to write a little equation here. We need a variable. We're going to let x equal the original number of people at the mall. So x equals original original number of people. Okay, x is what we want to solve for. So we only have one variable in this equation, and that's x. Okay, so let's go ahead and write an equation. From the original group of people, 40 of them leave. So we're going to have x minus 40. We have an x amount of people in the group minus 40 of them because 40 of them left. And we want to know what that equals. Well, it's found out that 3/4 of the original group is left at the mall. Okay, so the original group is x, and 3/4 of them are left. So it's going to be 3/4 times x on this side. Okay, be sure how we understand how we got this, because this is the most important part in solving a word problem, translating it from the word problem or the expression to an equation. Equations we can learn how to deal with. So it's the art of translating a word problem to an equation that most people struggle with. So be sure we get this. Okay, now we simply want to solve this equation for x. Well, what do? We isolate our variable x on one side and add everything else on the other side. So we can start off by doing this by adding 40 to both sides. We have a minus 40, so if we add 40, that's going to cancel. Whatever we do on one side, we have to do on the other side. Add 40 on this side as well. That's going to leave us with x on this side, and we have 3/4 x plus 40 on this side. Now all we need to do is move this x over to this side. So we have 3/4 x over here, so let's go ahead and subtract 3/4 x from a plus 3/4 x. That's going to cancel. We're going to do the same thing on this side. 3/4 x. So we're going to subtract that. That's going to give us x minus 3/4 x. And on this side, we are left with 40. So we subtracted 3/4 x from both sides. That canceled. And we're left with this. Okay, so now we need to subtract... Oh, both of these terms have x as a variable, so we can actually just subtract the coefficients. This has a coefficient of 1, and this has a coefficient of 3/4. Well, we can go ahead and write 1 as 4 over 4. And we want to do that because we can actually now go straight to subtracting the rational numbers because we have a common denominator of 4. So we had 1x, and we just wrote 1 as 4 over 4, because 4 over 4 equals 1. So we skipped a step there just to make things easier. So now 4 over 4 minus 3 over 4 is 1 over 4 x. Okay, and then we have 40 left on this side. One more step, we're multiplying x, our variable, by 1/4. So how do we undo multiplication? Well, we divide. We're going to divide by 1/4. We've got to do the same thing on the other side. Now, we saw in the section on dividing rational numbers that whenever we're dividing something by a rational number, we don't ask why, but we flip the second and multiply. So we're going to flip 1 over 4, so we have 4 over 1 times 1 over 4x. And we're going to do the same thing over here. We're going to have 40. We're not going to ask why, but we flip the second and multiply. So instead of dividing by 1/4, we multiply by 4 over 1. 4 cancels with 4, 1 cancels with 1, and we're left with x on this side. And on this side, we have 40 times 4 over 1. Well, we can actually just drop the 4 over 1 and just write 4, because we're multiplying by a whole number. So 40 times 4 is 160. So x equals 160. So that's the original number of people in our group is 160. Now we always want to check our answer. Let's go ahead and check it just to make sure we're correct. And we do that by substituting our value for x into our original equation. So we have x, which is supposedly 160, minus 40 equals 3/4 x. Well, 3/4, x is 160, so 3/4 times 160. Now, if this holds true, then that means our answer is correct. So we have 160 minus 40, which is 120, and 3/4 times 160. 3/4 times 160. Well, we can write this over 1, and we're multiplying two fractions, so we multiply right across the top, numerator, numerator, denominator, and denominator. 160 times 3 is 480, and 4 times 1 is 4. And let's rewrite this. 120 is on this side. 480 divided by 4 is 120. 120 equals 120 is a true statement, which means x equals 160 is the correct answer. It's a valid solution. Okay? So we always want to check our answer to make sure we got it right. It just takes a little bit more work, but it's well worth it. All right, we're running out of time. Let's do one more. Let's say a zoo charges a $10 entry fee. $10 entry fee to visitors. We want to find the money taken in if 120 people visit the zoo. 120 people. All right, so we're going to have two variables here. We're going to let y equal the money taken in. The money taken. And that's actually the variable that we want to solve for, because we want to find out the amount of money taken in. And we're going to let x equal the number of visitors. Number of visitors. Okay. So how we're going to write this? Well, we're going to solve for y, so let's do y equals. Y is the amount of money taken in. How do we find out how much money was taken in? Well, we're going to, if $10 is the entry fee, and we have X number of visitors, well, it's $10 for each visitor, so we're going to have 10 times X. Okay, well, in this example, we're going to let X equal 120 people. So wherever we see X, we're going to substitute 120 in. So we have Y equals 10 times 120. And that equals $1,200. So if the entry fee is $10 and we have 120 visitors, the money taken in is $1,200. Okay, I'll leave you to check this one. We know how to do that. We make sure we plug in 1,200 in for Y, and if this holds true, 120 in for X. If that holds true for our equation, then 120 is the correct answer. So be sure to check that, and I'll see you soon.